Okay, so let's kick it off here, of course, with just some review problems, some warm-up problems. Determine whether the following are functions. Now, two ways to do it, remember. You can look at the equation and mentally test it, meaning ask yourself, if I put one number in for x, do I get exactly one answer out? Or graph it on your calculator and see if it passes what test? Vertical line test. I don't care how you do it. What do you got? Yes or no for one?
Yes.
Yes. If I put a number in, if I put 5 in there, I get one answer out. Got it. All right, 2. No, because here's the problem. If you solve this for y, of course, which some of you might have done that, I mean, really you get to this step and you're like, ooh, I got to root it. And we know the devil's in the details with math. What would have to go in front of the square root? We're going to get 2 answers out. Big fat no. Okay. 3, x equals 8. Yes or no?
Wait, yes. No.
I see both. Okay, so before we answer, question for you. What type of special line is x equals 8? So if I try to do the vertical line test through it, is it going to hit more than once?
Yes.
Got it. All right, let's do some mental math for fun. Mental math, we don't need a calculator, and evaluate some functions. Let's put -2 in for x. So 2 times -2 squared minus 3 times -2 plus 7. Order of operations, my friends. Exponents first. What's -2 squared? Times 2. We're going to have plus 6 plus 7. Final answer.
Oh, wait.
21. Who needs a calculator? We don't. Might be a little calculator dependent. All right, let's put -1 in this time. Exponent first. What's -1 squared? This will be a final answer. See, we don't always have to rely on our calculators and type everything in, right? Right. Like the time I saw a kid in Algebra 1 type in their calculator -1 divided by 1. I almost had a stroke.
Just making
A
sure.
stroke. A stroke. Okay, so max and min. We're going to talk about maximum values and minimum values on a graph. Super easy. We're going to let our graphing calculators do the work for us on that, so that's going to be nice. Piecewise functions. Remember, those are the 2 or more equations. We've evaluated them. You've had to plug numbers into them. I'm going to show you how to draw the graph today. And then even odd. Even odd, you can do it 2 ways. You can do it algebraically. You can do it off the graph. I'm going to show you both. I never care how you do it, as long as you actually can do it. Okay? So let's talk relative max and min. You don't have the picture on here because we're going to look at some pictures here in a minute, but just to kind of get the idea. So of course the graphs we know go on forever, so that's why we're going to ignore those, and we kind of look through the curves. We're going to look for the highest point, of course min, we're going to look for the lowest point. So here you can see you've got these curves, you've got some high points, those would be the local maximums, minimums, the low points, okay? So we're going to have our calculator do all the work for us, which is really quite nice. So start graphing. I already kind of cheated and have the picture up here. I'm going to punch it in the calculator though and actually show you the functions for it. Now, just like increasing, decreasing, constant, you don't have to have all of it. You don't have to have both a max and a min. This one only has the min, the low point. Now, I mean, I could kind of maybe Hail Mary it and guess the ordered pair of it, but we want exact. So we're going to have our calculators find it. So I'm going to show you how to do that on the old calculadora here. So type it in, y equals. Let me clear this out here. I have 3x squared minus 2x minus 5. I'm going to zoom out just a little. So you've got the graph up there. Now we want that exact point. So super easy, your calculator is going to do it all. You're going to hit trace, second trace. You got to get into that calculate menu. We use that calculate menu a lot, just for the record in here. So second trace. Now it's to me kind of common sense. We need the minimum, so I'm just going to hit 3. And it pops the cursor up. Now you just need, it's going to ask left and right. You don't have to be super specific. I'm going to have the cursor somewhere on the left of the point. I'm going to hit enter. I'm going to cursor it over to the right side of the point. And again, it doesn't have to be, super specific. So I'm going to hit enter. I'm going to right arrow through the point somewhere on the right side. Good enough. Nobody wants to guess. That's just stupid. Texas Instruments. I'm going to hit enter. And there's our minimum. So I'm just going to, it didn't say what to round to. Let's just round to 2 decimal places. I'm going to put 0.33 and negative 5.33. 0.33. So on these problems on your homework, your calculator is going to do every single thing for you. And again, you could have both a max and a min. You might have 2 minimums. You might have 2 maximums. Just depends on the picture. This one we have both. I have a min. It looks like 0, 0. I mean, I kind of think it's 0, 0. I'm still going to have the calculator do it though, just to make sure it's not some weirdo decimal. And we do have this high point here, the max. And again, calculator's going to do it all for me, so same deal. Let's type it in here. So my y equals, I'm going to clear this out. Here we go, negative x cubed plus 3x squared. Got it. So I'm going to do the min first. Like I said, I think it's 0, 0, but let's just make sure. So I'm going to do my second trace, and we're going to do 3 minimum. So I'm going to just left arrow so my cursor's a little bit to the left side of that point, wherever on the left. Enter. Right arrow through it. Enter. Nobody wants to guess. Okay. Now, what does those crazy e's mean?
They're a very small number.
That's a very small number because that's the scientific notation for your calculator. This is really saying 4.78 times 10 to the negative 7, aka 0.000000. I lost track. 6 zeros, 6 zeros, 4, 7, 8. This would be 0.0000. 12 of them. Which, is that close enough to 0, 0 if we round it? Yeah, we're going to put 0, 0. I thought it was 0, 0, but always good to check. All right, let's get this max point. And then number 4, maximum. Let me right arrow, get him over there to the left side of the point. That looks pretty good, close enough. Enter. Right arrow through the point, somewhere on the right side. Enter. Nobody wants to guess. It's done. Okay, so I'm just going to round that. Let's say 2, 4. All right, let's put our points down and be done. I like this stuff. So my min, my hunch was right, 0, 0. And then the max, 2, 4. Yeah. So the first handful of problems, this easy. You don't have to draw the graphs. Just get the answers from your calculator. And like I said, you could have more than one min. You could have more than one max. You could have a mixture of everything. Topic number 1 of the day done. Next up, piecewise functions. We have evaluated these. We haven't drawn the graphs. Now, just to review, quiz next week, thinking about it, you've done things like f of 3, where you have to figure out which one to put it in. Oh, over negative 1, put it in the bottom. We've done that. Now we're going to draw the graphs. I'm going to do the top one in red. So I'm just going to rewrite this. I don't like to graph when it's in function notation, that f of x. I'm going to make it y equals. Now, can you use your graphing calculator for that? Yeah, but I mean, we should be able to draw this. And good review. What form is this in? Slope-intercept. I'm going to just M&B it. Now, if you're ahead of me, fine. Just don't draw in the solid line yet, okay? Mark it out. Y-intercept 6. Got it. Slope of 1. Up 1 over 1. Up 1 over 1. Now, we know I can't draw straight, okay? So I am putting a lot of points on here to help my cause. Now, I'm just going to put a dashed line through this. Kind of think of this as a template. Now, we are only going to bold in, or have for a final answer, a piece of the line. Which piece? This is what determines it. Your constraint. So I'm like, okay, all right, I got you. X-axis. So less than or equal to negative 1. Well, here's negative 1 on our x-axis. I'm going to go up and meet my line right here, equal to, so a closed circle, less than are going to be the numbers to the left. So that's the only piece of the line that's technically our answer. Now clearly you're doing yours in pencil. I don't care if you leave the dashes on, whatever. Power of the board up here. So that is technically the only part of the line we want. Again, I don't care if you leave the dashes on or whatever, that's totally up to you with your pencil. But again, just bold that in. Oh, let's go Christmas colors. Do this one in green. So same thing, I'm gonna mark it out. My M and B, I'm gonna dash it on, I'm gonna think of it as a template. And then we'll figure out what piece. Okay, so y-intercept -4, slope of 3, of 3 over 1. We all know I can't draw, so I put on several points just to help me draw the line straight. We've seen my lack of artistic skills. Okay, let's figure out what piece. And again, it's the constraint, aka the inequality behind it, that determines that. Greater than -1, x-axis, -1, bam. I'm gonna come meet my line. Here it is. Greater than, open circle technically, and greater than would be the piece or the points to the right. Again, you can leave your dashes on there, don't care, power of the board, I'm gonna erase it. Make it look good. So you do have a couple of those to graph today too. Again, your calculator will give you the lines, sure, but they won't give you which piece you're actually keeping of each part of the graph. So you are going to have to be able to do that on your own. So any questions on drawing those? All right, goal number 2 of the day done. We're on to the third thing, even odd. Now, a couple ways you can tell if functions are even odd. We can do it algebraic, you can do it off the graph. We're going to do both today. And your homework, there is both. It will say to do it off the graph, some off the algebra. Now, quiz, test time, I never care how you do it. It'll just say determine whether it's even or odd. Whatever makes the most sense to you. Okay, let's do even. Even. Both of them start the same way. Replace x with a -x. Okay, we're going to start with that. Simplify, and you get the original function. So that just means, just to kind of show you, or explain that to you to set one up. If I'm going to test this one, I'm going to replace all x's with a -x. Which is just tedious to write all this out, but that's what we would do. I'm going to come back, I will simplify that, we will finish it, but that's what it's referencing when it says replace x with a -x. Okay, back to it. Now, if you're a picture person, okay, you're good at the pictures, visualizing, you can also tell these are both even functions because geometry, they are symmetric about the y-axis. Now, a little throwback to geometry, y-axis. If you fold this over the y-axis, it matches up. That's what we mean by symmetric over the y-axis. Same thing here. Fold it over the y-axis, it matches up. So some kids are good at the picture, you can just quickly see it. Some, like the algebra, we're going to do both today to practice. All right, odd functions. So it starts the same, replace x with a -x, but this time you get the opposite of your original function. Now, what does that mean in math when we say opposite? That means we're looking at switched signs. Just to be specific, so your x to the 5th turns into -x to the 5th. We have opposite signs. Now, the graphs, to show you those, they are symmetric about what we call the origin. Now, I think that is a little trickier to visualize. Let me show you. Power of the board makes this easy for me. Okay, so here's our original graph. This one I have rotated around too. Let me flip it back here. Now, symmetric about the origin. We do that a little bit in geometry, but that is one thing we don't cover a ton of, so you might be a little rusty on it. So to figure it out, you gotta really be good at picturing this in your mind. So picture our graph, we're in quadrant 1, quadrant 3. To be symmetric about the origin means I can rotate it 180 degrees, either direction, half a circle, and it's the same function. So if I rotate this 90, there's a right angle, and another 90. Ooh, let me square it up. It is the same graph you started with. I think that's hard sometimes to see. I've literally had kids rotate their calculator on the desk. Do what you gotta do to see it. Same thing here. If I take this one and I rotate it 90, 90. It's the same function it started with. So that's how you tell the symmetric about the origin. So I'm just going to add a little note up here. You have to be able to rotate it 180 in either direction. So again, I don't care how you tell if they're even odd. I'm going to do algebraically. I'm going to do some off the graphs, as long as you can tell and answer it. Okay. So of course this one you can see I started the algebraic part. So replace x with a negative x. We did it. I'm going to simplify. Okay. 6 negatives results in a positive. 2 negatives makes a positive. So I'm going to have minus 2x squared. Then I'm comparing it against the original equation, the original function. X, exact same original function, it's even. If you graph it, you can fold it over the y-axis and it will match up. And we are going to do some off the graph here in a minute, okay? All right, let's do this one algebraically too. So replace x with a negative x. We're going to be super conscientious of the signs and we're going to simplify. 5 negatives makes a negative. Okay. 3 negatives makes a negative, but you have the negative in front, so the overall sign is going to be a. So we do not have the exact same original. We've got opposite. Positive to negative, negative to positive. When you have the opposite, odd. Got it. Okay. So this is one you could rotate it 180 degrees, and the graph will be the original you started with. All right, let's look at the next ones here. So let's do this one. I'll do it algebraic if you want to, but let's do it off the graph, okay? So punch it in your calculator, y equals, figure this out, x squared. Kind of looks like a Nike swoosh. Drag it over here. So if I'm going to test this, I'm going to test even first. Can I fold it over the y-axis and will it match up? So even out. Now I'm going to test. If I rotate it 180, is it still my Nike swoosh? Okay. So here's 90, 180. Is that our original graph? No? Okay, so we got a big fat none of that. We got neither. None of those things happen. Now, just to show you if you're like, man, I really hate looking at the picture. Like, that is not my thing. If you do it algebraically, you will see this is just a hot mess. Okay? We don't have the exact same original function, not even. We don't have all the opposite signs, not odd. Okay, we got neither of those. Let's graph this one and see what we can figure out. 4x equals, what is it, 3/5? So I'm just going to do 3 divided by 5, nothing fancy there. Type it in. Let's steal the picture over here. All right, first question, can you fold it over the y and would it match? Nope, not even. So let's see if I spin it 180. 90, 180. Is it the same? Odd. Got it. Maybe. I'm not grabbing stuff. So just so you know, FYI, your homework, there's a part that will say do it algebraically. Okay, all right. So technically you're supposed to be putting in the negative x's. There are some problems that say do it off the graph, okay, just to practice both on the homework. But quiz or test time, I don't care how you do it. It'll just say determine whether it's even or odd. You can do it however, whatever makes the most sense to you. The last thing with even and odd, find the coordinates of the second point on the graph. If the point is even, if it's odd. All right, well, let's set it up here. Let's do even first. And then we'll do odd. Okay. Okay, so remember, the test for even and odd, algebraically, it all started the same. Replace x with a negative x. Okay, well, if I replace this with negative 5/3, two negatives makes a what? So it's going to be 5/3. Now, same for odd. The process is the same. I don't want black, I want the blue. Come on. Replace x with a negative x. Starts the same. So switch the sign on the x. Okay. Here's where it really counts, is the y, of course. Even, you get the exact same original value out. So I just copy down -7. For odd functions, remember, opposite. You get the opposite value out. What's the opposite of -7?
7.
So easy. You just have to be super conscientious of the positives and negatives. That's it. That's all it is. You're done. You got it. It's not, Anna.
You forgot the negative on the 5/3.
Nope, both of them are positive. Remember, you replace x with a negative x.
Oh.
So I did negative 5/3.
Oh, yeah.
Yeah. All about the signs. Easy but tricky. Questions on that one? All right, let me grab